Hey guys, how's it going? Welcome to another Arduino Workshop. So, this is not the best title. We're going to talk about the loops that our code runs in and how that works. Are you good, Andy? How that works and how we can improve it. So, we've learned over the last 3 or 4 weeks that there's two major sections, the void setup and the void loop. Does anyone remember what we do in the void setup?
We determine what our variables are, or inputs and outputs want.
Yeah. So it's like a common function or a common thing that we do that we only have to do once in the void setup. What is one of those things that we do almost every single time? Like when we have an LED or we have a button.
Call pins and stuff?
Yeah, the pin mode.
Oh.
Yeah. And so, the void setup only runs one time. And then the loop function, whatever we put in the loop will run forever. And so the Arduino will execute the first instruction, then execute the second instruction, and work its way down the line. When it gets down to the bottom, it'll jump back up to the top. And it'll just execute that loop forever. So with that in mind, we're going to look at this code that I wrote in 5 minutes. First off, what does it appear that this code is doing? Yeah, so what happens if the button is pressed?
Turn off the button. Wait, no. No, turn on. It blinks if the button is pressed, right?
When the button's
If
pressed, does
button
it
state
lower
is
high?
low.
So let's say that when the button is pressed, the state is low.
Okay.
Oh, okay. So if the button's pressed, then it turns off the LED. Right?
Yeah, and then what is this while true thing going on here?
That's weird.
I don't know. I can spoil it.
No.
I like your perplexing code. It's very good.
So how does a while loop normally work?
While the whatever condition you put in the parentheses is true, it'll execute.
Mm-hmm.
Infinite while.
So what happens if we were to set, if the condition that we're giving it is true, then it'll execute the while loop. So we set it equal to true, the while loop will execute forever.
Okay.
And in this instance, we don't have any code in there, so what it's effectively done is stop. You could say it stopped the program, it stopped the code, but what it effectively did is put the code in a state that it can never get out of, and it just does nothing forever. So this is a good way, because I was talking about that loop, it runs forever, and basically whenever you power on the Arduino, it's going to run forever, but you can put it in this state where now it's doing nothing forever. So that's the first thing to note, that if you press the button, the LED will turn off, and then you'll put yourself in the state where the Arduino will never do anything again. If you don't press it, we will turn the LED on for 5 seconds and then turn it off for 1 second, and so we have a little blinking pattern. But can anyone see a possible problem with this code?
Besides the while loop?
So the while loop isn't a problem.
No.
That's actually, if you wanted to have the button turn off the LED and have it never turn on again,
okay.
that's a good way to do it.
Well, considering we're talking about the Millis function, probably something with the delays.
Probably. That's a good guess. Someone was reading it. How about if you guys want to come over here? I have it running on this Arduino right now. I don't know. Can you guys see this light fine?
Yeah.
Okay. I'll just talk about what's going on for the video. So we got this light blinking. You see it's blinking for 5 seconds, and then it turns off for 1 second. We can all see that. So while it's on, if I press the button and let go, it's still blinking. It's still blinking. So the button isn't really doing anything right now. But what happens if I hold the button? It's blinking, it's blinking. Oh, so now it turned off.
Oh, because it has to go through those delays before it can get back to being the loop again?
Yeah, exactly. Exactly. So while the Arduino, basically there's only one place where the Arduino is going to read what the button is, and that's right here on line 12. So anywhere else in the code, if you're pressing the button, it's not going to register that. Now luckily, with most instructions, the Arduino can process them very quickly. I don't know an exact number. I don't know if it's like a millisecond or whatever. It's nanoseconds, yeah. So even if you press the button really quickly, you're going to hold it down for more than a couple nanoseconds. But the problem comes when we use these delay instructions. So now the Arduino is basically doing nothing for 5 seconds, and any input that's happening, it's not going to capture. So the delay, I can talk about it here. So yeah, as I mentioned before, the Arduino executes lines of code sequentially. First is executed, then the second, and if any line of code is delayed or stopped, then the whole program must wait until this one task is completed. I guess like another example would be maybe you have a while loop that waits, like while the button isn't pressed, do nothing, and then when it is pressed, start doing something. But if that while loop waits forever for you to press the button, and you never press the button, then the code is always going to be waiting, and no other lines are going to happen. So this is an example of why the delay is not the best function to use. For one, if you're using the delay, it's just reducing the processing power of the Arduino. You could probably have the Arduino do a lot of things during that delay time and make your code more efficient. But then also the bigger problem is it can miss user inputs, or it can just cause things not to function correctly. So this is why we're going to want to use the Millis operation. So there's actually 2 ways that we could fix this timing issue. So using the Millis function and use that to get rid of all the delays in the code, in this example would fix the problem, and for most code that's a great idea, and that will probably fix a lot of problems, but it's not perfect. It won't solve all problems. So the other solution is using the interrupts, which is the best solution, but it's not really more complicated, but it's a little bit more work to do, and the Arduino only has 2 interrupts. So next week I'm going to talk about what interrupts. We're going to talk about interrupts and like actually use interrupts. But just real quick, what an interrupt does, basically in this example, we could set the pin that the button is connected to as an interrupt pin. And that means that if the state of that pin changes, the Arduino will it'll finish executing the line of code that it's on, but then it will immediately jump to a function that we declare and execute whatever's in that function, and then go back to the code. Say we're in this loop and we're right here. We're just turning on the LED high, and then suddenly the user presses the button. If we're using interrupts, the code could sense, okay, that button changed, and then before you execute this next line, we're going to jump over here and execute a function that we wrote. So this is the best solution for this kind of problem, because it's guaranteed that the Arduino is immediately going to execute the next thing, or execute what you want to do when the button is pressed. However, we only have 2 interrupt pins on the Arduino, so you can only use this to work with 2 buttons or 2 sensors or whatever it might be. So this could be a motivation to use a better microcontroller than Arduino, because honestly, one of the things that I'm most frustrated with the Arduino is it only has 2 interrupts. The Arduino Mega, I think, has 4 or 6 interrupts, which helps.
For
but like,
reference, the Pico, which pretty much all of us are using for mining right now,
think 32, and that's only in like the types of interrupts. Literally every pin can
Yeah,
interrupt.
yeah.
It's like 64 software interrupts or something stupid.
Yeah,
It's
the
insane.
better microcontrollers, pretty much every pin can be an interrupt. So, yeah, one of the disadvantages of using an Arduino, but it's great for learning. So anyway, we'll talk about interrupts next week. So right now we're going to talk about Millis, this Millis function. What it does is it returns the amount of time that has passed since the program first began running, and it returns it in milliseconds. And so this allows us to kind of have a clock, and so we could capture when a task started, and we know how long the task should last, and then we can always compare our current time to our started time and see how much time has passed. So, for example, with this LED, you turn the Arduino on, in 100 milliseconds after it started, the LED turns on. And then we know after 1,000 milliseconds, we want the LED to turn off. So as soon as the current time passes 1,100 milliseconds, we can switch the state of the LED. And that's actually what we're going to do right now. So if you guys want to go to open up the Arduino IDE, and then here, I can do this as well. If you just go to Files up here, go to Files, Examples, Digital, Blink without delay. And then just click on it, and it'll open up a piece, some code, and then you can start looking over that code. You can also connect the Arduino and run it. It uses pin 13 as the LED, so you can just use the built-in LED.
I guess while they're doing that, is this just out of curiosity? Is this based off the system clock? I'm guessing it was sort of like an RTC on this.
I believe so. I don't know off the top of my head. I mean, it wouldn't it have to be based off of?
Well, because you can have a real-time clock that like stores actual time, or you can have you're just measuring the ticks.
Oh,
Like
I see what
the
you're
Pico
saying.
has both, so that's why I'm curious. Because I've been using I have been using the system clock. I just I don't know. That's the presentation left there.
Yeah.
And then doing something manually like that, kind of like doing your own like counter clock thing, wouldn't work because you still have the same issue with the loop, right? Like if you set like a variable and like you mean like did your own little
Oh,
clock,
state for every loop.
essentially.
Well, that would only increment as much as your loop.
so
if
it's
your
really
loop,
the same problem, kind of.
I mean, that would be the same thing basically. Because
Yeah.
what the system clock does is it ticks for each physical clock cycle.
Mm-hmm.
And that's like 48 megahertz. It's probably 100 something kilohertz on this thing. But
Okay.
whatever the system clock is,
Mm-hmm.
every time that ticks and the processor receives, does some sort of register
Yeah.
manipulation, it just simply queries that value. So it stores that value, so
Okay.
how many times it's ticked. So this is all just electronics. Like this
Oh,
is
got it,
electronic
got it, got it,
software.
got it, got it.
And the software can read that in assembly, and that's what it does. From my understanding of this.
So this says that certain boards use timer 0 to generate Millis, and then the ARM boards and SAMD boards use system tick timer.
Okay.
So the system tick timer, just every single instruction, it increments a tick, and then
Every clock of every system clock. So
Oh, okay.
Because some instructions take like 3 cycles.
Mhm.
Each like the picos at 125 megahertz. that
Mhm.
clock would take 125 megahertz. So just every time the CPU received,
Okay.
do an instructor or do a register manipulation, whether that be part of one instruction or a single instruction, that would all work.
Okay. That makes sense.
So I guess in the Arduino then it's using a timer purple, it looks like. Is that
Yeah.
cool?
Because I'm pretty sure ours counts as a ARV board,
Yes.
AVR board.
Yeah. Data type is it like a unsigned long?
Unsigned long, yeah.
Does it actually count that high? Or does it roll over? So
I believe it can count that high. It says it will roll over after 50 days. So.
Oh.
That's very Arduino documentation. Well, you can do the quick math knowing it's on timer 0 when the frequency is timer 0. I mean, that's an incredibly big number, even at like a couple megahertz that would take.
Well, I'm pretty sure this is the milliseconds, so it would be 4,294,967 seconds.
Oh, right, it returns milliseconds, not just timer tips. Yes, okay, never mind. That's 50 days. I don't think our tiny cards are gonna last that long. We could do the 50 days of Le Mans in our tiny cards.
Yep, it's 49.7 days. So if your car is on, or if your Arduino is plugged in for that long, then this function won't work. So yeah, if you guys remember data types, so the long data type is a 32-bit number, and that can store between 0 and 4 billion. Yeah, 0 to 4 billion. So it can store a big number, which makes sense because we're working with milliseconds. So if you're on for an hour, that's a lot of milliseconds, but this unassigned long will be just fine.
Unsigned long is actually bigger because it's doesn't have negative.
Yeah.
So it's bigger by a lot. I don't know how much, but it's probably a little bit.
Well, this one says 0 to 4 billion. So I think an assigned 2-bit
It's gonna be
is
just,
less.
It's 2 to the power of 31. That is.
Anyway, did you guys plug in your Arduino and run the code? Is it doing anything exciting? Yeah, it doesn't look that exciting, but what it actually does is kind of important. So if we look in the code, so this is cool. The LED built in just means that it's going to automatically default to the built-in pin. So on the Arduino Uno, it's pin 13. On some other Arduino boards, the built-in LED is on a different pin. With this variable LED state equals low, we also have this previous milliseconds variable, which you'll notice is an unsigned long. We set the pin mode output, and then at the beginning of every loop, we're going to read in how many milliseconds have passed since the Arduino is powered on and capture that in the current milliseconds. And so then we can subtract the current milliseconds minus the previous milliseconds to see how long of an interval since the last time the LED has changed state. So previous milliseconds only gets changed. So let's say you start the program. Previous milliseconds defaults to 0 up here. And then you're going to run this loop. And you're going to run it a couple times before, 1,000 milliseconds have passed by. So then finally your current milliseconds is going to equal 1,001. You subtract 1,001 minus 0, that's greater than 1,000, because your interval your interval is basically set to how long you want the LED to be on and off for, which is done up here. So current milliseconds equals 1001 minus 0. That's greater than the interval. So now we're going to actually change the state of the LED. We're also going to capture the current time in the previous milliseconds. So now the next time we go around, we're going to compare to the last time the state has changed, which will be set in this previous milliseconds. So next time we go around, say it's been 1010 milliseconds since the Arduino's been plugged in. So we take 1010 minus 1001, so only 9 milliseconds have passed, and we need to wait a lot longer. And so by recording the time when the state changes, we can always make a comparison from that time to see how long has passed. And then this code is just a way to change the state of the LED. If it's low, we're going to set it high. If it's high, then we're going to set it low, and then we're going to digital write the pin to the LED state. So, yeah, hopefully this doesn't look too intimidating. Does that make sense to everyone? Laura? Lose my voice. Sorry. Jane, are you already on level 2? You're not looking ahead in the PowerPoint, are you?
No, of course not, Joe. Why would I do that?
Well, the next step is going to be kind of building off of this code. So even if you wanted to copy and paste this code into a new Arduino script, you could do that. Well, we want to wire up an LED and a push button, and initially the LED is going to turn on and off, blink at a rate of 1000 milliseconds. But if the user presses the push button, holds it for, we'll just say 5 seconds, and then lets go, now the LED is going to blink at a 5-second rate. It's going to be on for 5 seconds and off for 5 seconds. So basically the first step is implementing what's kind of already implemented, is having an LED change state based on a certain interval. And then the second step is reading in how long the user presses the button and setting a variable to capture that. So first step though is just wiring up an LED and a push button, which is pretty easy. Hopefully you guys remember. Well, how about we all come back together and we code it together.
This is my. I want to make sure.
Yeah, there you go.
Alright, so
Time out.
Wait.
No, to go do your thing. I'll cover it.
Evan, are you pretty close to this?
Yeah.
Okay. Actually, we're going to add what Laura did in a second. So this is very similar to the blink without delay. Got the LED pin. We also declared a button equal to whatever pin our button is. We have a button state, so we can record what the state of the button is later. I also have this button is pressed, which might come up later. And then the previous milliseconds and the LED blink time is what we used before to have the LED change state based on what time it is. Which is basically all of this right here is the old code for having the LED change state based on how much time has passed. But instead of using interval, I changed the variable to this LED blink time. I also didn't make it constant because we're going to change that based on what the button does. So then in the loop, one of the first things we do is read what the state of the button is, and then we have these conditional statements based on what the button is. And as Laura coded, we're going to need 2 more variables. Unsigned, long, what did you call them?
Button press and button release.
Okay, I'm going to call it button press time. just so it's a little more clear. Then in here, so the button is released. And then, Laura, what did you write also if it's released? You subtract the 2, right?
Yeah, so I did button release time minus button press time equals LED flow
So does this make sense to you, Evan? How we, well, so the way I have it wired, when the button's low, that means it's pressed.
Okay.
So that's why I wrote in here if the button is pressed. So if it's pressed, you record button press time. Then if it's release, you record the current time, and then you subtract those times to get how long the button was pressed.
Yeah.
So with this, we're almost there. The only problem is if we press the push button, every single time we run through this loop, button state is going to equal low, and we're going to reset button press time. So if we ran it right now, and then as soon as we push the push button, say we press the push button at 1,000 milliseconds have passed, button press time is going to equal 1,000. But in the next loop, button press time is going to equal 1,005. Because right now the only condition is the button pressed. So what we need to do is we need to have another condition, which is why I put these 2 and signs. So we need this other condition. And what I was going to use as the other condition is this button is pressed, or maybe we could label it button was pressed. Basically, this will store the last state of the button. So when you first press the button's going from it wasn't pressed to it is pressed, and that's when you want to capture the time. The next loop, it's going to go from it was pressed and it's still pressed, and we don't want to do anything there. And the same thing, when it's released, it goes from it was pressed to it's not pressed. So the state has changed, so now we want to do something. But the next time, when it hasn't changed, when it's not pressed to not pressed, we don't want to do anything.
Okay.
So if this button was pressed, we're going to set it to false, because currently the button's not pressed when the code first starts. Then here we'll say if, how do we want to say this? No, we'll say button is pressed. Okay, so when you first run the code, button was pressed is equal to false. So the first time you press it here, button is pressed, was pressed is going to be false. I cannot spell.
It was fun.
It's just so awkward.
Yeah,
Usually it's like you're not stressed about writing the wrong thing because
Yeah.
whenever you're typing in front of you, you're like,
I know. Of course.
No offense, but you guys don't scare me too much.
really?
If you guys were professors, it'd be a little different.
No, but still, even like.
I can critique your code if you want.
Yeah,
Oh, I'm sure you can. I know it's bad.
We can bring doing the extreme programming practices.
You want to calculate the big O?
Pass sitting over your
That's all of this is constant time. No, just don't worry. Your algorithmic efficiency of an if statement is
Let's go.
You've gotten that exponential if statement. Yeah.
Okay. So what we've done here, the first time around, button was pressed is going to be false because your button's not pressed. The first time you press it, this condition of button state equals low is true. Also, the button was pressed is still equal to false because that hasn't changed. So the first time you press it, this condition's going to happen. We're going to set the time, and then we're going to set button was pressed to true. So the next time around, when we loop around and we get here, button state is probably still low because even if you press it super fast, you're gonna hold it down for a couple of milliseconds, and this code's gonna run much quicker than that. So button state's still gonna be low, but button was pressed is now true. So this part of the condition isn't true, so then this isn't gonna happen. So we're only gonna capture the time the first press.
Yeah.
Up here, when we finally release the button and the button state goes back to being high, then button press was true. Well, it last was set to true, so this is going to be true the first time we release it. So we can capture the current time, we can subtract the 2 to get the... Oh, I did this wrong. Wow. Okay, now I'm embarrassed. Thanks, Shaden. You set the variable at the beginning.
Does that actually work?
Yeah. So you capture what the time is, you can subtract the time to get your LED state, and then you can set button was pressed to false, because now the button is no longer pressed, it's up. So the next loop, this button state's still going to be high, because you're released, you haven't pressed it, but button was pressed is false, it's not true, so this won't happen. So this way we kind of have a flag to store the last state to help trigger these if statements only once. So we're going to see if this works.
Okay. Do I still set runtime outside of if statements?
Yeah, because you just recalculate. Start and end don't change until the
Okay.
button state changes.
Okay.
So
In
Sweet.
theory,
you
that's
could.
Well, it works for me.
start as a global
So if you guys want to try it,